Hello, and welcome to the Amazon Web Services Partner Webinar Series. Our topic today features mobile and enterprise apps and API on the AWS cloud. I'm your host, Sherry Sullivan. I'm with the Partner Marketing Team here in Seattle, and I'd like to welcome you today. We'll start with just a couple housekeeping items before we get going. So I'd like to remind folks that we do record today's session, and we do make our presentation materials available on the AWS SlideShare as well as YouTube channels. I'd also like to remind folks that there's a Q&A web part in your browser, and please feel free to submit questions anytime during this webcast, and we'll take a few moments at the close to address your questions. And be assured that if we don't get to them during the webcast, we will follow up with you directly afterwards. I'd like to let you know that today we'll be covering an overview of Amazon Web Services as well as security models, AWS Identity and Access Management, otherwise known as IAM, and we will then jump into Intel sharing an overview of API development approach, a use case, and a free trial offering, and again, closing with Q&A. I'm pleased to be joined today by Travis Broughton, who is the Enterprise Architect at Intel, along with Ryan Holland, who is one of our Ecosystem Solution Architects here at Amazon Web Services. With that, I'd like to turn it over to you, Ryan, to take it away.
Thank you very much, Sherry, and thank you everyone for joining us today. So I wanted to start with a quick high-level overview of what AWS is as a platform. So a lot of folks might be familiar with EC2 or S3, a lot of our compute and storage services, but it's really a platform that has a whole host of services that surround our core compute, database, and storage. These services span from application services to help customers deploy applications in the cloud or to manage or monitor those applications, as well as some very important networking and security services, as well as services that handle identity and access management as well as monitoring. And all of these services are available on top of our global infrastructure, and they're used as building blocks for customers to build their applications on top of these services. So I spoke about the global infrastructure that all of these are sitting on top of, and it really is a very big and large global footprint. As you can see, our global footprint spans 5 different continents, and it is comprised of 9 different regions. And that's a somewhat specific term for AWS. So what we mean by a region is a collection of highly redundant data centers that are in a particular geographic area. And we refer to these data centers as availability zones. And these availability zones are where customers will launch their applications and store their data. And those are all designed to be fault boundaries such that any kind of failure within one availability zone won't affect any of the other availability zones within a region. And we have been growing this global footprint over the past years, and you will continue to see expansion of this footprint as we add additional capacity to our existing regions, as well as add additional regions across the globe to meet the needs of our customers. So I want to talk about a little bit why customers are moving their workloads to AWS. And in general, we see 5 value propositions that customers are attracted to. The first one, trading capital costs for operational expenses and lowering your overall cost of ownership for a particular service or for some servers or storage, is typically one of the first things that customers see value in. But as they start to get more familiar with our platform and they start to use our services, a lot of times we see customers really getting a ton of value out of our flexibility and the ability to not have to guess on capacity going forward. So the nature of our platform allows you to create storage or compute resources in seconds versus weeks or months in a traditional data center. And it also, very importantly, allows you to tear those resources down and stop paying for them if that particular resource is no longer necessary. So this gives folks the ability to very quickly get new initiatives out to the market and to try in different initiatives and have very low cost for failure as well. And you don't have to guess and make projections for multiple years about how much storage or compute that particular service is going to need. You can grow your infrastructure as the number of customers that are using that service grows. And then lastly, the ability to go global in minutes. So I just talked about our global footprint for all of our data centers, and this allows you to place your application or your resources close to where your customers are. So if you want to expand to a new region, you don't have to now go and purchase data center space or buy an office in that particular country. You can leverage our global footprint to move your application close to your customers. So now that we've talked at the high level, I want to talk a little bit about security. So the topic of this webinar is enterprise and mobile applications and APIs. And so I wanted to start off and describe our security model and then talk about how we manage API access to our platform. So when we look at security on AWS, it's a shared responsibility model. And what we mean by that is there's going to be certain parts of the overall deployment that we're responsible for securing, and this will be the infrastructure. So everything from the physical building itself all the way up through the virtualization layer is going to be the responsibility of AWS to manage and to secure. And we go to great lengths to do that. That is by far our number one priority. And we go through a very long list of different certifications and audits on our processes for that as well. Security of the applications itself, though, everything really an operating system and up, is completely in the control of our customers. And so it's your responsibility to secure your applications and secure your operating systems. But this is also where our partner ecosystem comes into play to help provide you tools and applications to help you secure those assets. And then lastly, at the bottom, we have some security services that are features or functionalities of our different services that customers can leverage to enhance their security posture. And on the topic of APIs, I wanted to talk about identity and access management and specifically how we manage access to APIs in our infrastructure. So we have a service called IAM, or Identity Access Management, which is what is used to create and control, create user identities or create API keys, and then also create policies and control which users or applications are allowed to access which of our infrastructure APIs. And so with IAM, I can create multiple users, and I can group those in groups, and I can create specific policies around what each of those users or groups can do, which API calls to our infrastructure they can make. But it's important to draw the distinction that this really is only for creating and controlling access to our APIs. So APIs for the AWS infrastructure. And if you start looking at APIs that your application is exposing, that's where partner solutions like the Intel Expressway, Express Gateway will come into play. So when we look at how we can extend this to mobile users, we have another service that's part of IAM called our Security Tokens service that allows you to create temporary security credentials. And this is extremely useful for very large deployments or where you're going to have mobile or browser-based applications that need to interface with the underlying infrastructure. And this allows you to, on the fly, create a short-lived set of API credentials that you can pass back to that mobile application or that enterprise application and give them a very specific set of APIs that they're allowed to leverage on our infrastructure. So from a diagram of how this would work, if I had a mobile application or a pool of users that need to access something through a browser, and I want to give them access to the AWS Service API. So this would be something, again, that's modifying the set of resources that you're running in AWS, maybe uploading or creating a new object in S3, or starting or terminating an instance in EC2. These are all examples of AWS Service APIs. And you can do that by authenticating from the mobile application to your session proxy or your authentication store, which will leverage our security token service to create a short-lived, very specific set of API keys that can be passed back to that mobile device, and then they can interface with the APIs for our services. Now, if the API that you're looking to control or to provide security for lives in the application that you're running, then that's where, again, our partner ecosystem would come into play, and solutions such as that from Intel will be very appropriate. So with that, I'll hand over now to the folks at Intel to talk about the Intel Expressway API Manager.
Thanks, and thanks again, everyone, for joining this morning. So my name's Travis Broughton. I'm an enterprise architect in Intel's Data Center Software Division, and I'll be talking about, as Ryan said, taking your own APIs and exposing them through the Amazon Web Services Cloud and making them secure and integrating them with other apps and services that may be in the cloud or may be on-premise in your own data center. So APIs are a fairly hot trend right now in enterprise architecture. There's a lot of enterprises adopting APIs as a way to provide higher availability, scalability, and resiliency for their apps as they move to the cloud, and to provide better access for handheld and mobile devices. The growth in bring your own device and other types of mobile access drivers from enterprise are really causing people to rethink how they deliver applications and whether they're being delivered as monolithic applications within the enterprise data center, or whether they're being delivered through APIs that can be consumed from a number of different locations and from a number of different platforms. So really, the other benefit to APIs is that they turn the enterprise into a platform, and by that I mean they take data and services and other assets that have historically been locked up inside the corporate firewall, and they expose them in a way that they can be consumed by different devices and by partner developers or other developers, and that provides an opportunity for the enterprise to monetize some of those data and services. It extends the reach, and you see companies basically taking what was previously just some internal secret sauce and exposing that in a way that it can be consumed by other developers and charging a fee for that. So the API is becoming a product. But if you're offering that up as a product in a SaaS model, you need to secure it. You need to make sure that you manage the SLA, and you may have different pieces of information that you want to integrate together to deliver that API as a product. So according to Programmable Web, there are over 9,000 public APIs, and then behind that there are an unknown number, probably much higher, in private APIs. I know from my experience in Intel IT, Intel has its cloud services platform. We have a few other APIs that we expose publicly for developers that we advertise through a portal. We have a tremendous number of internal APIs, a lot of that legacy SOAP and other protocols that are internal web services that are used to run our business. REST, however, is becoming dominant, and if you want to surface APIs in a way that they can be consumed by mobile devices or by partners, REST and JSON is the model that they expect. So there's a growth there. We also see from reading various analyst reports from Gartner, Forrester, and others, I think the stat of 75% of Fortune 1000 comes from Gartner. 75% of Fortune 1000 companies will offer one or more public APIs in the next year or so. And we're also seeing, as a result of companies moving to virtual private clouds and moving to hybrid cloud usage models, as well as companies that are just going all in and going to the public cloud, we're seeing a lot more integration flows that extend outside of the enterprise firewall. So data services are being integrated internally and externally outside of the company, and that's driving some increased cost in integrating those data and delivering them in a consistent way that's usable by employees and usable by partners, usable as a product. The other driver, or another driver for the growth of APIs, primarily private APIs, is again the move to the cloud. So as companies move their legacy applications to the cloud to be able to gain some of the benefits in terms of cost and agility and performance that come from hosting in the cloud, taking a service or taking an application and just dropping it in place as it was in your on-premise data center to the cloud is not the best practice. So from reading what the Open Data Center Alliance recommends and what some of my colleagues at Intel IT recommend, there's really a need to re-architect apps as they move to the cloud. Inside your on-premise data center, you can effectively gold plate your infrastructure. You can invest in a very high performance and very high reliability individual nodes, and you can take and put in redundant power supplies and redundant disks, and that's a very costly infrastructure investment in order to deliver high availability for these mission-critical apps. What we're seeing in the cloud is going the other way, which is to move the responsibility for availability and for security to the application itself. So instead of depending on a firewall to keep everything out and depending on a server that costs $50,000 to build because it's got RAID 1 and mirrored disks for redundancy, failover power supplies, and all of that sort of stuff. We're going with lower cost commodity types of servers, but deploying multiple instances of each component of the application. And so applications are being decomposed into sets of services, and those things are more loosely coupled. And then as those services are deployed, one of the other benefits is that scale can be delivered where it's needed. So instead of trying to take this sort of scale-up architecture where if you think you're going to have peak demand, you size your server for that peak demand and you deploy 64 gigs of RAM if that's necessary and 32 CPUs if that's necessary. You deploy just a number of different instances and you can scale up and down as necessary for each of those components. Now, the way that you take those loosely coupled components and recompose them together to deliver an application is through APIs. Each of those different modules generally will talk to each other through APIs, through web services, through a RESTful interface. And so that is driving some significant growth in the number of APIs that we're seeing deployed. And again, these are largely private APIs internally, but then to talk to the client and to connect back to enterprises or partners, there will then be some external-facing APIs as well. So as an example architecture from the Open Data Center Alliance, here are a couple of sort of reference architectures from them. On the left, we have a single app that's decomposed into some different modules that all use APIs to communicate with each other. So they use infrastructure as a service or platform as a service to deliver sort of the classic logic tier. Then an API is used to connect to a persistence tier, whether that's a table, a database, an object store like Amazon's S3, or a table store like DynamoDB or one of the other Amazon database services, and then potentially integrating other third-party SaaS offerings through APIs, whether that's for authentication or social posting or some other integration of capabilities for basically off-the-shelf, out-of-the-box functionality that gets added in through additional API calls. And then on the right, we have more of a deployment architecture there, where we've got the services deployed and multiple instances of each service. And externally facing, we have some APIs that are used, load balanced for the client to connect in. And then internal, inside the cloud or inside the data center, we have additional APIs that are used to provide functionality or persistence for the services that the client's talking to. So some indirection there and some additional ability to scale independently. So if one of the services is more active than the other, it can be scaled up independently, and that helps control cost. And then it can be scaled back down when the demand has passed. So as I mentioned with the last slide, some of these architectures are becoming more complex. So one of the challenges there becomes integration. There was the example of Facebook in the earlier architecture. There are, even within an enterprise, as an enterprise adopts a hybrid cloud model, they may have data and services that are hosted at Amazon and in the public cloud or in a virtual private cloud. They may also have a private cloud on-prem within their own data center, and then they may have legacy standalone enterprise systems. And to provide a single interface that's orchestrating connectivity across those multiple back-end data sources, there's a need to effectively create a mashup of these hybrid data sources and to centralize that security layer so that you don't have to open up the firewall to allow access to all of those services from anywhere on the internet, but provide a centralized point of control to basically limit your attack surface. And security in general is a big concern. Again, as you're moving from one monolithic application to a number of APIs, internal and external facing, that potentially increases your attack surface dramatically. Instead of having to secure one application, you now potentially have to secure 2, 3, or even a dozen APIs and manage access to those. You also have to take sort of a defense in depth approach because there are a number of different vectors that can be used to attack these APIs. So at the perimeter, there's the risk of denial of service. There's various code injection exploits. There's internal types of injection and security types of risks and attacks. And basically being able to protect in depth can add a lot of complexity to each of these APIs to make sure that they are each secured appropriately, and even authenticated devices and even authenticated users, whether intentionally or unintentionally, can serve as a threat. If you're doing a bring your own device type of model, if an attacker is able to compromise that device, and that device is still authenticated to your service, there's the potential that they can try to do something malicious in sort of a side channel or through what looks like a legitimate and authorized connection. So again, security, there are a number of different threat vectors that can be used, and there's a need to have a fairly sophisticated approach to dealing with securing a number of APIs. Identity becomes another challenge. The old way of doing things, the way that we do things within the data center is different from the way that things are being done on the internet today. So inside the enterprise, you probably have Active Directory or LDAP or Kerberos or another enterprise identity and authentication type of system. You may be using SAML assertions and some other things for your internal web services or with legacy SOAP security models. On the other hand, on the internet, a lot of those things don't really exist. Mobile devices and apps, app developers use API keys, and mobile devices and consumers coming in through web service types of interfaces are using OAuth. They may be using a social identity. They may be logging in with their Twitter or their Facebook credentials or a LinkedIn credential. So the way that those identity capabilities are managed, again, are two different systems, and enterprises really can't afford to deploy another identity silo, a third mechanism for managing identity and access control. And enterprises also aren't ready to deploy API keys and OAuth and some of these more modern types of web service authentication mechanisms inside their data center. I suspect that in 10 years we may be there. We may be using social identity everywhere, and it may be the case that down the road we'll have enterprise systems that instead of using LDAP, just use the same type of identity management system that's being used for mobile. But we're not there today, so that mapping needs to be created and needs to be maintained. So one approach to doing that and to managing security and to managing integration and managing the identity and basically to secure and deploy these APIs is obviously through code. So as you develop the application or deploy an application to the cloud, if you're using Rails, you may import a number of Ruby gems that give you the ability to do social identity management, to authenticate through Facebook or Twitter or what have you. You may have some Node or PHP libraries JavaScript libraries that you're using, but that adds a fair amount of complexity to the application or to the API. So managing all of this across a number of APIs, making sure that your security policy is consistent, that it is enforced consistently, to make sure that a uniform policy is deployed, and to make sure that it is kept current and up to date, because these threats continue to change, and we see a number of exploits in the wild. We see different types of code injections and other vulnerabilities being announced and needing to be patched on the common application stacks. So every few weeks or months, you'll see a new version of some of these libraries needing to be deployed because of a vulnerability that was found. So keeping current on that, keeping them up to date, and keeping them uniformly enforced, making sure that they're audited, that adds time and complexity that really isn't value add for the enterprise. It's not delivering any unique functionality. It's not necessarily giving you anything that's going to give you a competitive advantage. It's not giving your employees any additional functionality that they'll be able to leverage to make them a more effective worker. It's just adding time to your development cycle. An alternative approach to adding code is through more of a visual policy. So the approach that we advocate is the gateway approach. So having a centralized interface that as you deploy your API, you can create a policy. You can create a default policy that will be deployed for another using a policy that can be used across a number of different apps and APIs, and being able to use the same, it's being able to verify that the same policies or your policies that you have standardized on are being employed at every level, making sure that you can do through just visual inspection, making sure that they're available and making sure that they're being enforced. The gateway approach allows you to do that, and it reduces your overall attack surface. So basically this gateway approach gives you the policy enforcement without having to deal with the complexity of coding. And that's one of the benefits of our product, Expressway API Manager, provides the ability to do that through a centralized visual interface. It allows you to more quickly deploy APIs and surface new APIs. You can do a mashup or do a workflow to surface a legacy data asset, whether it's a SOAP service or a SQL database, and provide a RESTful facade as the front end of that will be that will be integrated with the API itself, and then the client can integrate with, or the partner can integrate with that, and so you surface your API without having to do a lot of coding and additional work on the logic tier for simple APIs. We also support WebSockets, which is a relatively new protocol for bidirectional streaming or bidirectional data access. So instead of having to do this kind of transactional model of HTTP, you can have more of a persistent data connection between the mobile client and the back end, and we can provide some pass-through security for that. We support we support OAuth APIs. We support basically the security policies that can be used for identity management and access control for APIs. And then we can help to also enforce SLA. So we can set a policy that enforces traffic level and protect against denial of service types of attacks. So again, we support WebSockets, which we have two models of WebSocket support. So we can do basically pass through and do some protection against different types of attacks through WebSockets, and basically a sort of a pass through model support for WebSockets, mediating with a WebSocket enabled backend. But the other thing that we can do that's kind of interesting is we can effectively upgrade a non-WebSocket aware app to provide a WebSocket type of capability. So some of the internal data center polling that would be done, traditionally the client would do the polling all the way to the back end, and that can be fairly costly. With this model, the gateway can do some of that polling on the behalf of the application and can pass the result back to the client without the client having to poll as often, and that reduces the effective latency. It reduces traffic, and it can basically reduce the overall cost because a lot of these devices are on a limited data plan. This it's very scalable. We can support almost linear scale for inbound connections, and this was designed with mobile and large scale enterprise deployments in mind. A couple of other use cases that we have, again, the mediation use case of providing access to basically a mix of assets in the back end and surfacing them in a way that they can be consumed by a variety of devices. So in a few slides, I'll give a link to our website, cloudsecurity.intel.com. And if you go there and you look on some of our presentations, we have a customer testimonial from a video game, an online gaming company, Ubisoft, that uses a very similar usage model to this, where they have a number of different devices, whether they're consoles or handheld devices, connecting in to a REST JSON API. But in the back end, they have a mix of legacy services that they need to be able to connect to. So they have some XML, they have some JSON, they are trying to add some big data types of capabilities through Hadoop, and being able to provide a single consistent RESTful API interface and a common convention that can be used by developers, and providing availability through some failover types of capabilities there. All of those are very important to them in delivering an online service. They also talk in their in their video about the need to be able to scale elastically for seasonal demand. So demand spikes that come with the Christmas season, or that may come with Black Friday shopping, depending on the use case for your particular enterprise, being able to scale up to meet that demand and then to be able to scale back down again without having to have your environment sized for peak demand is something that's very important. So being able to have that load balancer at the front end, being able to have multiple instances of APIs and multiple instances of the API management layer that can all scale up and down is critical. Another use case that we have is being able to provide a mapping between, again, as I mentioned, the models that are being used by web and native apps, whether they're expecting to use OAuth or API keys or OpenID rather to assert an identity, and then on-premise identity management and authorization systems, being able to provide that mapping in a way that allows an internal user when they present some other identity to be mapped and to be known, and then to be able to provide that edge threat detection. So being able to be upstream of the API and provide that consistent security policy for the hybrid cloud, for mobile devices. Expressway API Manager has all of that built in. So we do the identity mediation, and we can do some of the authorization piece as well. And then we can support these newer mobile devices without having to make change in the code. You'd still have to implement the policy. You still have to put together a workflow that will support that and implement that in the gateway. But once you've deployed it to the gateway once, and once you have that workflow defined and created, it's easy to pattern that out and reuse that across multiple APIs. So you don't have to modify the code multiple times. You can basically develop it once and deploy it multiple times and not have to change the different applications. So the product is now available in the Amazon Marketplace. It's completely self-service, so as opposed to being a bring-your-own-license type of model, the software and the compute container are billed hourly. You pay as you go through a credit card. You don't have to do a separate license or engage with Intel Sales. You can just go and deploy it and try it out. If you use it and scale up, scale down, you'll only be billed for what you use through Amazon's marketplace system. It is still the same enterprise-grade platform that we offer for on-prem deployments, and we've offered in the cloud as a virtual appliance. This just provides the ability to deploy it through Amazon Marketplace for your own environment and to be able to scale up and scale down. So we're now offering for the next month a limited time trial. So we have a free trial offer. The way this works is you need to start sometime in the next month and use the standard Excel instance. If you look at that in the marketplace, you'll see that the software cost is free. And if you use 190 hours or more in the next month or by the end of August, then you will receive effectively a rebate or a credit back for the $120 of EC2. So we want to make sure that you're using this to actually try it out and not just getting an arbitrary EC2 credit that you could use elsewhere, but we are providing the ability for you to try this out for free over the next month. And again, you have to use the standard Excel instance. If you look at the page in the marketplace, that's the only one that has the free software price right now, and that price will revert to the standard pricing at the end of the trial. Also, if you are interested, we're also offering some free consultation time, 30-minute, hour-long phone call to talk about your use case. If you send an email to this asipcustomercare@intel.com, you can also connect with us with some of our experts to talk more about your use case and what type of architecture you might be able to use to get started or to perform an evaluation to see if this meets your needs. And lastly, I'll just wrap up with a couple of other resource pages. So if you go to cloudsecurity.intel.com, that's our main product page. We have all of our products listed there. EC2-security is the landing page that talks a little bit more about the offering that we have in the Amazon Marketplace. And then the link on the right is to the Marketplace instance where you can go ahead and purchase the software or get the software deployed into your cloud app. So with that, I guess we'll open it up to questions.
Great, thanks, Travis. And folks, if you've joined us midstream, we invite you to submit your questions. And again, be assured if we don't get to them during this webcast, we will follow up with you directly post-event. So with that, we've got some questions coming in, and Travis, I'd like to point this one back to you. Intel is known for hardware. Why does Intel care about APIs? Can you elaborate on that?
Sure. So as I mentioned, I work in Intel's data center software division, and what we're seeing is that the platform, the compute platform, is increasingly expanding to encompass the data center and to include the cloud as well. And really, all of these different cloud usage models are depending on APIs. They're depending on some of the new services. So the group that I work in specifically, we work on the Intel distribution for Apache Hadoop, which a lot of Hadoop is managed through APIs itself. We're contributing work to Lustre. We do Intel's Data Center Manager. So all of these things consume APIs. They're built on APIs. And looking further out at Intel's investment in APIs, that really reflects that sort of emphasis and that investment in the API ecosystem. So we've recently acquired Mashery, which is the leading API portal. There's we've invested in or acquired Apona, which also is in the API space, and we have our Intel Cloud Services platform that developers can use to develop new mobile apps. So Intel is making a lot of investment in the API space, and it really reflects the blurring of the lines between sort of the data center and the cloud and really even the server. It's all becoming one big environment, one big ecosystem now.
Great. Thanks, Travis. The next question, and I will point this back to Intel, is if I launch APIs in your Express API Manager in AWS, can I use it to manage my APIs on-premise, across my own data center?
Yeah. So sorry. Can you repeat the question there?
Sure. The question is, if I launch the APIs in your Express Manager on AWS, can I also use the Express Manager to manage those APIs on-premise in my own data center?
Oh, right. Sorry. Yeah. So we have you can. We offer an on-prem version of the software. So depending on your architecture, we probably need to discuss a bit further. But you could do a hybrid cloud model where the main point of connection is the Expressway API Manager in the Amazon cloud, and then it can connect back, just like we connect back in to provide a bridge for identity and authorization through connecting back into Active Directory. You could also connect back into on-prem hosted APIs, but you could also set up, deploy an on-prem instance of Expressway API Manager and have local connectivity there as well. So it really depends on the architecture and what you're trying to do with it.
Okay, great. Thanks, Travis. Another question of Intel, so keep those questions coming in, folks. Does the use case that you articulated, Travis, mean that if I have existing enterprise services, do I need to move them to the cloud, or all I need is the API manager to interface with AWS Cloud Services? So I think folks are asking basically how that works once they utilize the Expressway.
So I think it's a little bit like what I was just saying about on-prem versus cloud. You can manage on-prem APIs through and enterprise services through the Expressway API Manager, and so basically what you would do there would be you would poke the right hole in your firewall to let Expressway API Manager living in the Amazon cloud talk to the services that live in your DMZ or live inside your enterprise firewall, and then you've helped to manage the attack surface there. You're giving that one point of ingress is from a known and managed system. So it's a way that you can basically mediate access into a resource that lives inside your firewall. So you'd effectively be using Amazon as a DMZ in that case. But to really move the service to the cloud and to interface with, to get the full benefit of the cloud in terms of elastic scaling and all of that, you may want to take some of those system services, particularly if they are something that can be decomposed into kind of standalone modules and deploy them in the Amazon cloud as well. You'll probably get a bit better performance there, and you may see some improved cost or resiliency by hosting it in AWS.
Okay, thanks for clarifying, Travis. The follow-on question, and Ryan, feel free to jump in as well on this one. The question is, can you elaborate on the IMA token authentication system? Specifically, what components are managed for you by AWS, and what components are built and managed by the developer?
Sure, yeah. So the IAM token authentication system that I talked about in the beginning, just a reminder, that's for access to our infrastructure APIs. And the component of that we're managing is really just the creation of those tokens. So the distribution of those tokens and the authentication of the requester is done by the customer on your side. We do have some sample code on our documentation site that shows you how you can create one of those session proxy servers to forward that over. But the use of those, or the distribution of those API keys and the initial authentication to the mobile device would all be done by the customer side. We just handle the creation and passing those keys back to your session proxy.
Great. Travis, I will point this one back to you. Is the Expressway API gateway different from Expressway service gateway Intel currently uses? And they're wondering what kind of security it offers.
So it's effectively the same product, just repackaged as a virtual appliance that's deployed in the Amazon cloud. So that it provides the same security capabilities. The Expressway is actually a line of products. So we have Expressway Tokenization Broker, Expressway Service Gateway, Expressway API Manager. So the different products have slightly different capabilities and functionality, and you can look at our website at the different data sheets to see which one would be most appropriate to you. But if you're already using Expressway Service Gateway and you have a workflow that you've created through Services Designer, or you have policies that you use through the web interface, those should work. You should be able to just drop them in on your Amazon instance and go.
Okay, great. This question is related back to services and security models. So I'll point this back to you, Travis. The responder is asking if like iOS or Android and HTML5 clients are considered equally secured in the service.
Yeah, I think so. I mean, really, it's just an API. So the access, you're exposing the same thing regardless. So if it's an HTML5 app, if it's an Android native app, if it's an iOS native app, in terms of securing the device itself, that you would have to take up with your IT department or with whomever is providing security and managing security for the devices themselves. But in terms of securing the back-end API, regardless of what's connecting in, whether it's Android, iOS, or HTML5. We don't differentiate it. It's just an API. So it provides the same interface, and it provides the same security.
Great. Thanks for clarifying. And we've got time for just a couple more questions, but this next question I'll again point back to you, Travis. How frequent are updates to the API Manager?
So right now we are releasing probably about 4 to 5 releases per year with our on-prem product, and we'll probably be doing a similar cadence to that through Amazon Web Services. So the engineering team is always looking at new capabilities that people are wanting, that they're using, and new things that are being deployed in, especially mobile. There's a lot of changes and a lot of activity in mobile architectures right now. So we're looking at those and trying to stay on top of them to make sure that we support what's going to make for a compelling app.
Okay, great. And one additional question, and Ryan, feel free to jump in here as well. Is it easy to move from cloud to on-premise to install these API Manager? Does that make sense, the question, guys? Okay, we'll take that one offline. Final question, I'm going to point this back to you, Travis, is can you talk a little bit more about the security models? What security models do you support?
Yeah, so I guess I spoke to this a little bit on a couple of the slides, but really, if you look at like OWASP's top 10 threats for perimeter defense, we support basically all of those. We also have the ability to do mapping between OAuth and the enterprise security systems for on-prem identity management. So we've got a pretty wide variety against content and code injection and denial of service, a pretty broad spectrum of security capabilities.
Great. Well, with that, I would like to invite folks again to take advantage of the limited trial offer that Intel has put together, and connect, reach out, and get those questions answered directly from Intel. And the information is right there on the slide. So with that, I'd like to thank our alliance partner, Intel, and Travis Broughton, who is the enterprise architect, for joining us today, as well as Ryan Holland, our ecosystem solutions architect. And on behalf of all of us at AWS, thank you for your time and your interest. And before you jump off the call, we do invite you to take a very brief survey. It helps us improve our webinar series, and we do look at your feedback and take it serious. So thank you very much for your time, and that concludes today's webcast.